NVIDIA Nemotron 3 model release and evaluation. NVIDIA has entered the reasoning model arena with Nemotron 3, a hybrid architecture that attempts to solve one of local inference's persistent headaches, the trade-off between context length and speed. The model combines Mamba 2 layers for handling long context, low-latency inference with transformer attention blocks for fine-grained reasoning, an architectural mashup that's becoming increasingly common as researchers try to escape pure transformer limitations. The numbers tell an interesting story. Nemotron 3 packs 31.6 billion total parameters but activates only around 3.6 billion per token through its mixture of experts design, a configuration that should theoretically deliver the reasoning capability of a much larger model at a fraction of the compute cost. NVIDIA claims up to 4x faster inference than Nemotron Nano 2 and 3.3x faster than competing models in its size class. The 1M token context window positions it for retrieval-augmented tasks and persistent memory applications, though the Hugging Face model page lists 128K context for the 30B A3B variant, suggesting some confusion about which configuration ships with which capability. Perhaps more significant than the benchmarks is NVIDIA's commitment to transparency. The release includes open weights, datasets, training recipes, and critically, the complete evaluation methodology through NeMo Evaluator. This addresses a growing credibility problem in the field. Without reproducible evaluation recipes, it's impossible to determine whether reported improvements reflect genuine advances or merely optimized benchmark configurations. NVIDIA's approach allows anyone to rerun the evaluation pipeline with identical prompts, harness versions, and runtime settings. Early community testing shows promise for consumer hardware. One user reports running the Q8 quantized version with MoE CPU offload on a modest RTX 2060 Ti, 6GB VRAM with 48K context at 15 to 18 tokens per second, genuinely usable speeds for interactive work. The model includes reasoning controls with on-off modes and a configurable thinking budget to cap reasoning tokens, addressing the unpredictable inference costs that plague extended thinking models. Deployment through vLLM and SGLang should smooth integration for teams already using these serving frameworks. Local AI hardware and deployment. The dream of running frontier-class models locally continues to push hardware configurations into increasingly creative territory. A detailed build log on local LAM-A documents an 8X Radeon 7900 XTX system representing roughly $6,000 to $7,000 in hardware investment. Significant, but a fraction of what enterprise GPU clusters cost. The configuration achieves 192 gigabytes of total VRAM across the 8 cards, connected through a $500 PCIe Gen 4 X16 switch expansion card from AliExpress that provides 64 additional lanes on a consumer Z790 motherboard. Running a 99GB GLM45 Air Q6 model at 131K context, the system delivers approximately 437 tokens per second for prompt processing and 27 tokens per second for generation at empty context. At around 19K tokens of context, those numbers drop to 200 plus T per sec prompt processing and 16 T per second generation, still comfortably usable for interactive work. Average power consumption during inference hovers around 900 watts. Community discussion raised valid concerns about whether the Vulkan backend, running through LMS Studio on Windows 11, is fully optimizing the multi-GPU configuration. The builder acknowledges this isn't the cheapest or most plug-and-play solution, but values the upgradability and customization flexibility. For those who've invested time learning the quirks of AMD's ROCm ecosystem and multi-GPU setups, the reward is genuine long context capability without cloud dependencies. At the opposite end of the spectrum, a demonstration of Agent Santa shows a complete voice AI pipeline running on a $250 NVIDIA Jetson Orin Nano with no internet access. The stack combines OpenAI Whisper, Tiny, Liquid AI's 700M parameter LFM2, and new TTS for text-to-speech, all consuming under 4GB RAM and 2GB VRAM. This demonstrates that meaningful on-device AI doesn't require bleeding-edge hardware. The constraint is matching model capability to available compute. For mobile deployment, Unsloth has documented a pipeline for getting LLMs onto iOS and Android devices using Executorch, the same technology Meta uses across Instagram, WhatsApp, and Messenger. The workflow applies quantization-aware training to recover approximately 70% of accuracy lost to aggressive quantization, then exports to a 472 MB file. Qwen 3.6b runs at roughly 40 tokens per second on an iPhone 15 Pro, fast enough for responsive interaction. The approach supports Qwen 3, Gemma 3, Llama 3, and other popular model families. AI model comparison and benchmarking. The latest round of frontier model comparisons pits GPT 5.2 and its Pro variant against Claude Opus 4.5 and Gemini 3 across 3 structured coding tasks. Prompt adherence, implementing a Python rate limiter with 10 specific requirements. Code refactoring, fixing a 365-line TypeScript API handler with SQL injection vulnerabilities. And system extension, analyzing a notification architecture and adding matching handlers. The results suggest different models excel in different operational contexts. Opus 4.5 completed all 3 tests in 7 minutes total with a 98.7% average score, the speed benchmark for teams prioritizing throughput. GPT 5.2 showed meaningful improvement over 5.1 in requirement adherence and cleaner output, with the 40% price increase deemed justified by the testers. GPT 5.2 Pro occupied a more specialized niche. It spent 59 minutes on the system extension task, identifying and fixing architectural issues that no other model addressed. That's impractical for daily coding, but potentially valuable for security audits or critical system design where correctness trumps speed. One commenter noted GPT 5.2's verbosity as a practical concern. The model tends toward extensive status messages and documentation that, while thorough, can be counterproductive for quick iterations. The underlying lesson: model selection should match task requirements rather than defaulting to most powerful available. Meanwhile, academic research continues pushing at fundamental transformer limitations. A new paper introduces DERF, dynamic error function, a normalization-free alternative that outperforms layer norm, RMS norm, and the recently introduced dynamic TANCH across vision, speech, and DNA sequence modeling. The function, defined as IRFA-X plus S, where IRF is the rescaled Gaussian cumulative distribution function, emerged from a large-scale search for designs that constrain extreme values while maintaining training stability. The researchers attribute performance gains primarily to improved generalization rather than increased fitting capacity, suggesting the benefits should transfer across domains rather than being benchmark-specific. AI development tools and SDKs. Production LLM applications share common pain points. Prompts bloating with unnecessary tokens, no systematic quality improvement process, injection attacks slipping through, and version management headaches across deployments. Prompt Manager, a new open-source Python SDK, attempts to consolidate these concerns into a single toolkit. The library offers compression, 30 to 70% token reduction through lexical, statistical, code-aware, or hybrid strategies, enhancement, both rules-only and LLM-assisted modes, generation, zero-shot, few-shot, chain-of-thought templates, and validation, injection detection, jailbreak attempts, unfilled templates. Benchmarks show lexical compression completing in 5 milliseconds with 40% reduction, while validation runs in approximately 2 milliseconds. The provider-agnostic design works with OpenAI, Anthropic, or any provider through LightLem, with options for SDK, REST API, or CLI usage. The Model Context Protocol, MCP ecosystem continues expanding. A straightforward tutorial demonstrates creating MCP servers for use with Llama and OpenWebUI, while a more ambitious and admittedly dangerous project gives OpenWebUI agents the ability to manage their own OpenWebUI instance through the full API. The tool includes 4 components: context inspection, API search, documentation retrieval, and API execution. The developer explicitly warns this version is for experts only, noting the obvious risks: data destruction, secret exfiltration, configuration damage, and the hypothetical but entertaining possibility of rogue AI behavior. Auto updates are enabled by default, creating an additional attack surface if the upstream repository is compromised. The long-term vision is making self-hosted AI accessible enough that non-technical users could manage family instances, but that safety work remains ahead. Multimodal AI models. Text rendering has long been a weak point for image generation models. The classic, "don't look too closely at the signs" problem. Ovis Image 7b tackles this directly. Delivering text rendering quality, the developers claim, is comparable to 20B-class systems like Qwen Image and competitive with GPT-4o in text-centric scenarios. The model specifically targets prompts demanding tight alignment between linguistic content and rendered typography: posters, banners, logos, UI mockups, infographics. At 7B parameters, it fits on a single high-end GPU with moderate memory requirements, supporting both low-latency interactive use and batch production serving. Integration options include the diffusers library via a custom fork or direct PyTorch inference. The architecture builds on Ovis U1, converting visual tokenization into a format compatible with autoregressive generation. Audio editing receives similar attention with Step Audio Edit X, a 3B parameter model specialized in expressive and iterative audio editing. Beyond zero-shot TTS cloning for Mandarin, English, Sichuanese, and Cantonese, the model enables iterative control over emotions: angry, happy, sad, excited, fearful, surprised, disgusted, and speaking styles: whisper, serious, exaggerated, child voice, etc. Paralinguistic editing supports 10 types of features: breathing, laughter, various surprise sounds, sighs, and filler words. The model requires approximately 32 GPU memory and runs on a single L40S or equivalent. For teams building voice interfaces or audio content tools, the combination of style control and dialect support addresses real production needs. AI privacy and security concerns. A security investigation by COI has uncovered that Urban VPN proxy and 7 related browser extensions, collectively installed by over 8 million users, have been secretly harvesting complete AI conversations from ChatGPT, Claude, Gemini, and 7 other platforms, then selling this data for marketing analytics purposes. The technical mechanism is particularly aggressive. When users visit targeted AI platforms, the extension injects dedicated executor scripts, ChatGPT.js, Claude.js, Gemini.js, etc., that override the fundamental browser APIs handling network requests, fetch, and XML HTTP request. This wrapping technique intercepts raw API traffic before the browser renders it, capturing user prompts, AI responses, timestamps, and conversation IDs. Data is packaged and sent via post message with the identifier Panelos message. The irony is sharp. These extensions market themselves as privacy and security tools, and Urban VPN carries Google's featured badge, indicating it passed manual review and meets a high standard of user experience and design. The data collection is enabled by default through hard-coded flags with no user-facing toggle. The only way to stop harvesting is complete uninstallation. Perhaps most concerning, the collection operates independently of VPN functionality. Whether connected or disconnected, harvesting runs continuously. The finding highlights a fundamental vulnerability in how people interact with AI assistants. Users often treat these conversations as private, discussing personal dilemmas, health questions, financial details, work frustrations. The assumption that this data stays between user and AI provider breaks down when browser extensions can intercept everything at the network level. For anyone using AI assistants for sensitive work, the lesson is clear. Audit your browser extensions and consider using AI platforms through dedicated apps or clean browser profiles. AI applications and use cases. Traditional vector search struggles with goal-oriented queries because semantically different content ends up far apart in embedding space. A user asking "what's the status of mobile launch" needs to retrieve code changes from engineering, PR strategy from marketing, App Store checklists from operations, and timeline documents from planning, content that shares a goal but not vocabulary. Paper addresses this through intent vectors that group memories by user intent rather than semantic similarity. When content is added, the system detects the user's goal, finds related memories serving that goal, combines them, and generates a new embedding stored near product launch goals rather than scattered across topic clusters. The approach claims 91++ retrieval accuracy on Stanford's Stark benchmark, testing multi-hop reasoning across semantically different sources, versus approximately 60% for pure vector search. The system combines this with automatic knowledge graph extraction for structured analytics, exposing a GraphQL API for dashboard generation and pattern queries. In a more whimsical application, Claude Code helped a user crack open a password-protected Word document from 25 years ago. The AI was organizing the user's file system when it encountered the locked document, a legitimate recovery scenario rather than adversarial hacking. The user reports Claude never refused or questioned the task, apparently inferring legitimacy from context and file metadata. The incident illustrates both the utility of AI assistance for personal data archaeology and the nuanced judgment these systems can apply when context makes intent clear. Academic research expands AI into vehicle recognition with a zero-shot approach that shifts the problem from image domain to text domain. The pipeline converts vehicle images into descriptive textual attributes using vision language models, compares against a textual feature database, and uses retrieval-augmented generation to infer make and model. The key advantage: new vehicle models can be incorporated through text descriptions without retraining on image datasets, addressing the continuous model introduction problem in automotive markets. The method improves accuracy by nearly 20% over clip baselines. Hardware hacking continues finding novel AI applications. The Landell Mailbug, an obscure email appliance combining keyboard and text display, has been repurposed as an AI terminal using an ESP32 microcontroller, querying ChatGPT and outputting responses via both character display and text-to-speech. Development utilities and tools. Self-hosted tunneling typically means trading convenience for control. Third-party services offer simplicity while routing your traffic through their infrastructure. Drip, a new Go-based tunneling solution, attempts to eliminate that trade-off by providing unlimited bandwidth tunneling through your own servers with your own domains. The latest version, 0.5.x, switched from a custom multiplexing protocol to Yamux, HashiCorp's battle-tested stream multiplexing library used in Console and Nomad. This change removed approximately 60% of protocol code while improving stability, a reminder that production-proven dependencies often beat custom implementations, even elegant ones. The tool supports HTTP, HTTPS, and TCP tunneling with detached background mode and can forward to any device on your network rather than just local host. The protocol break means both client and server must upgrade together. For Comfy UI users working with text-to-image generation, Comfy UI Z-Image Utilities provides LLM-powered prompt enhancement using the official Z-Image system prompt. The toolkit supports OpenRouter Cloud APIs, local API servers, or direct Hugging Face model loading with 4-bit, 8-bit quantization for consumer GPUs. Features include vision language model support for image-aware enhancement, multi-turn conversations with persistent history, and automatic cleanup of LLM artifacts and thinking tags. A password generation utility demonstrates regex constraint generation, creating passwords that satisfy multiple constraints, length, character classes, required symbols simultaneously.